Welcome back. We're doing Math Quest 2012, Math B, Chapter 8 AD, Question 17. Alright, let's get right into it. The cross-section of a road tunnel entrance is shown at right. All measurements are in meters. Good, so meters. Oops. Oh, holding the other side of the pen. Meters. And the shaded area is to be concrete. So I suppose this is concrete, supposed to be concrete area. Yeah, all these. And then find the exact area above the entrance, which is to be concrete. So we have to find the area of the shaded areas. Okay, so that's the first one. So now, it's fairly easy. All right, so because it's just finding areas between between two lines. So we got the bottom one, right? That this is the bottom one. It's a sine function. But what about the top one? Do we know what this is? It doesn't look like it, but the tricky thing is, let's look at the amplitude of the sine function with 5. Right? So that means it goes up 5 and goes down 5. All right? So this means this must be at least 5. All right? So the tunnel have to be at least 5. So there would be, so this particular area, this particular height would be 5, at least. So, all right, so that's it. That's where your second function, this is your top function, is y equal to 5, because it have to be at least 5 meters, right? The measurements are in meters. The tunnel have to be at least 5 meters high. So, well, what are we waiting for? Let's find the integration. Oh, we also need this point here, right? We also need this point here, right? Now, if you pay attention to this is developing the questions. So let's write down what we can do. We can write down from 0 to somewhere we don't know, right? It's 5 sine. Oh, sorry, no, it's top minus bottom. And then integrate with respect to x. All right, so we need to find out this x point here first. This x here. What's the x? All right. So what we're seeing here is half of a sine circle, of a sine cycle, right? We know that the other half is the bottom bit. So half of the cycle. All right. So we're looking for if we can find the period of the sine curve of the f of x. Then halving it will give us what that x value is. All right. So let's find the period. Now the period has something to do with so the normal standard function of sinusoidal function is y equal to a sine bx plus c plus d. All right. So that's the amplitude. B is something that we use to find the amplitude, the period. So B is equal to 2 pi over t, where t is the period. Yeah. So t is just equal to 2 pi over b, right? So let's look at our b. The b is the coefficient of x, right? Whatever, or the constants multiplying x with. So whatever in front of x is pi over 30. So this is literally t equal to 2 pi divided by pi over 30. Yeah? And we can change the divide to multiply by flipping it. Right? So now the pi cancels. So it's 2 times 30 is t equal to 60. So we know the full sine curve completes, one full cycle completes in 60. So half of it will be 30. So we know that, therefore, this bit must be 30, 0. This coordinate must be 30, 0. So good. Now we found whatever that thing is, which is 30. So we can put it on here. And we can start integrating. All right, 0, 30. Now top, remember top is the y equal to 5 function, right? That line there. So it's 5 minus whatever the bottom function is, 5 sine pi x over 30. Integrate with respect to x. Yeah. So that's equal to, so expand the brackets, 5 minus 5 sine x pi x over 30. Integrate respective x. Alright, is there something we can simplify? I suppose we can take out the common factor 5. Well, let's just do that. Let's take out the 5 common, because alright, so that becomes 1 minus sine pi x over 30. Yeah, we just took the common factor out. Alright, let's integrate. 5 multiplied by, so 1 integrated with x becomes x, minus sine, you integrate that, becomes negative cos, right? Whatever inside whatever inside the bracket never changes, and we divide it by the derivative of the brackets, which would be pi over 30. Yeah, and then 0 to 30. Alright, let's tidy things up. This is 5 multiplied by x minus become a plus, so cos pi x over 30 divided by pi over 30. Remember, it's just like multiplying by 30 over pi, so it's give you 30 cos over pi. 0, 30. Alright, let's sub the things in. Alright, just ignore the 5 for now. Alright, so ignore ignore this 5 at the front. So let's just do whatever is inside that first. So that would be, so let's put a big bracket around here. So that would be 30 plus 30 cos 30, so pi multiplied by 30 over 30, and then that's it. That would just cancel, equal to just pi over pi minus 0 plus 30 cos, not sine, cos pi over 30 multiplied by 0 all over pi. So that would give us 30 plus, now pi, cos pi is negative 1. So it's 30 times negative 1, it's negative 30 over pi. Yeah? Minus, so 0 is just gone, alright? So cos 0 times pi over 30 becomes 0. Cos 0 is positive 1. So it becomes positive here, pi. Right? So that becomes 5 multiplied by, so 30 minus, because it's a plus minus, it becomes minus 30 over pi, minus another 30 over pi, therefore it's minus 60 over pi. Right? So that gives you, let's find a common denominator, which is pi, so 30 pi over pi minus 60 over pi. Does that make it easier? Let's just calculate it out. I think this way is a bit confusing. Let's just calculate that out. All right. So 30 minus 60 over pi. So that gives us around 10.90. And 5 multiplied by that is 50. So times 5. 54.5. 4.5. And what is the unit? Meter square. Because we're looking for the areas, right? So that's it. That's the area of the entrance, which is to be concreted. Therefore, since it's approximation, you know, we go to the estimate equal sign. So the what's it called? The exact area. Oh, are you serious? They want the exact area. Oh, okay. So, all right. I guess we do have to do it that way then. The exact area. So the exact area is, so let's go 30 pi over pi minus 60 over pi, and then that's equal to 5 multiplied by 30 pi minus 60 over pi. Yeah, and then times 5 into it equals 150 pi minus 300 over pi. Right, and then we can split the two again, split the fraction again, pi over pi minus 300 over pi. So that is just 150 minus 300 pi meter squared. Right? That's the answer. Yeah, I didn't read the question. They wanted exact value. So this is the exact value. No decimal, no nothing. All right, so therefore the exact value of what? Of the exact area above the entrance, which is to be concrete. The exact area, not exact value. The exact area to be concrete as the entrance of the tunnel is 150 minus 300 over pi meter square. Yoo-hoo! Perfect. Last bit. The exact volume, oh, there we go, exact again. The exact volume of concrete required to build this tunnel if it's 200 meters long. So we're just adding another dimension to it, which is 200 meters long, right? So this is 200 meters. Something like that, yeah? Another dimension. Oh, let's finish drawing that. Yeah. Ooh, something like that. Something like that. So, easy. The volume is equal to area. Yeah, just like I said last question. Area multiplied by another dimension, whether it be length, height, or width. Alright, so which is 150 minus 300 over pi multiplied by, what is the 200 meters? Multiplied by 200. So that will give us 300. Yeah, 300 minus 60,000 over pi, and this time it will be meter cube. So that is the volume. All right, so what's the answer? What's the question? The exact volume of concrete required. Therefore, the exact volume of concrete required is 30,000 minus 60,000 on pi meter cube if the tunnel is 200 meter long. Right, like that. And that's the perfect answer for question 17. All right, so just under 15 minutes. Whew. My hand's getting sore. My hand's becoming sore. It hurts. It burns. But hey, it's good. Doing math is good. All right, so let's head into a commercial break, and we come back with question 18, which I believe will be the last question of chapter 8AD.